Hi friends, welcome to all. In this video we are going to see the lab activity building a switched network with redundant links. Here we can see our addressing table. Also we will go through the objectives of this lab activity. In part 1, build the network and configure basic device settings. In part 2, determine the route bridge. In part 3, observe STP port selection based on port cost. In part 4, observe STP port selection based on port priority. Also, we will go through the background. Redundancy increases the availability of devices in the network topology by protecting the network from a single point of failure. Redundancy in a switched network is accomplished through the use of multiple switches or multiple links between switches. When physical redundancy is introduced into a network design, loops and duplicate frames can occur. The spanning tree protocol, that is STP, was developed as a layer 2 loop avoidance mechanism for redundant links in a switched network. STP ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop. So in this lab, we will use the show spanning tree command to observe the STP election process of the route bridge. Also, we will observe the port selection process based on cost and priority. Here we can see required resources. We need 3 switches, 2960, also the cables. Coming to part 1, build the network and configure basic device settings. In part 1, we will set up the network topology and configure basic settings on the switches. Coming to step 1, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. So we are going to build and design this topology on our Cisco packet tracer. Coming to switches, 2960 switches. And we will rename the switches S1, this is S2 and this is S3. Also we will connect the switches. They are the same devices, so here we have to use a copper crossover cable. Fast Ethernet 0/3 to 0/3. Also fast Ethernet 0/4. Fast Ethernet 0/4, F0/1, F0/1, F0/2, F0/2, then fast Ethernet 0/3, F0/1, F0/4, F0/2. Coming to step 2, initialize and reload the switches as necessary. Coming to step 3, configure basic settings for each switch. So we have to do all these basic settings on all these switches. Disable DNS lookup, configure the device name as shown in the topology, assign class as the encrypted privileged exit mode password, assign Cisco as the console and VTY passwords and enable login for console and VTY lines, configure logging synchronous for the console line, configure a message of the day, that is MOTD banner, to warn users that unauthorized access is prohibited. Configure the IP address listed in the addressing table for VLAN 1 on all switches. Then copy the running configuration to the startup configuration. So we will do all these basic settings on our 3 switches. First of all, we will do it on the switch S1. Enable configure terminal. No IP domain lookup, host name as S1. We will enable secret as a class. Also we will go to line VTY 0 to 15, password as a Cisco, login. Also we will go to line console 0, password as Cisco, login, logging synchronous, and we will set banner MOTD. Unauthorized access is prohibited. Now we will set the IP address as per our addressing table for the interface VLAN 1. Here we can see the IP address of ES1 192.168.1.1. Also we can see the subnet to mask. We have to go to that interface VLAN 1, IP address 192.168.1.1, and the subnet to mask 255.255.255.0. no shut. Copy running config, startup config. Now we will do it on the switch ES2. Enable configure terminal. No IP domain lookup. Enable secret as class. Now we will go to line VTY 0 to 15. Password as Cisco. Login. And now we will go to line console 0. Password as Cisco. Login. Also logging synchronous. And now we will set message of the day banner MOTD. Access is prohibited. Right. Also now we will set the IP address for the interface VLAN 1. We have to go to that interface VLAN 1, then the IP address 192.168.1.2, then the subnet to mask 255.255.255.0. no shut command. Copy running config, startup config. Here we did not set the host name, so we will do that. Configure terminal, host name as ES2. Once more we will copy. Running config, startup config. Now coming to the switch ES3. Enable configure terminal. No IP domain lookup. Host name as S3. Enable secret class. Line VTY 0 to 15. Password as Cisco. Login, and we are going to line console 0. Password as Cisco. Login, and also logging synchronous. And we will set the banner MOTD. Unauthorized access is prohibited. Also we have to set IP address. So we have to go to that interface VLAN 1, and we have to set the IP address 192.168.1.3, 255.255.255.0. no shut command. Copy running config, startup config. So we have done all the basic settings on all these three switches. Now we will come to step 4, test connectivity. Verify that the switches can ping one another. Can S1 ping S2? Can S1 ping S3? And can S2 ping S3? Troubleshoot until you are able to answer yes to all questions. So we will test this connectivity now. Coming to S1. Password is Cisco. Enable password is class. Here we are going to ping to S2 192.168.1.2, and here we can see success rate is 100%. Now we will ping from this S1 to switch 3, that is 1.3. Here we can see success rate is 100%. Now we will ping from S2 to this S3. Coming to S2, ping to 192.168.1.3. Here we can see success rate is 100%. So here we can see our answer, everything is yes. Now we will come to part 2. Determine the root bridge. Every spanning tree instance, a switched LAN or broadcast domain, has a switch designated as a root bridge. The root bridge serves as a reference point for all spanning tree calculations to determine which redundant paths to block. An election process determines which switch becomes the root bridge. The switch with the lowest bridge identifier, that is BID, becomes a root bridge. The BID is made up of a bridge priority value, an extended system ID, and the MAC address of the switch. The priority value can range from 0 to 65535 in increments of 4096 with a default value of 32768. Coming to step 1, deactivate all ports on the switches. So coming to S1, before that we will see all the interfaces using the show command to show IP interface brief, and here we can see the interfaces fast Ethernet 0/1 till 24. Also we can see 2 gigabit Ethernet 0/1 and 0/2. We are going to deactivate all these ports on this switch S1. Configure terminal interface range fast Ethernet 0/1 till 24. Also we have a gigabit Ethernet 0/1 and 2. Here we are going to shut down these interfaces. Shut down. Right. Now we will do it on S2. Password is Cisco. Enable. Password is class. Configure terminal interface range fast Ethernet 0/1 till 24. Also gigabit Ethernet 0/1 and 2. Shut down. And coming to S3. Password is Cisco. Enable class. Configure terminal interface range fast Ethernet 0/1 till 24 and gigabit Ethernet 0/1 and 2. Shut down. Coming to step 2, configure connected ports as trunks. So on all the switches we can see total 4 ports, that is from fast Ethernet 0/1 till 4. So we are going to configure those connected ports as trunks. First of all we will do it on S1. Configure terminal interface range fast Ethernet 0/1 till 4. Switch port mode as trunk. Now we will come to S2. Configure terminal interface range fast Ethernet 0/1 till 4. Switch port mode as a trunk. Coming to S3. Configure terminal interface range fast Ethernet 0/1 till 4. Switch port mode as a trunk. Coming to step 3, activate ports F0/2 and F0/4 on all switches. We will do it on S1 first. Configure terminal. We'll go to those interfaces range fast Ethernet 0/2 and fast Ethernet 0/4. No shut. So change the state to down. Okay, right. So coming to S2. exit interface range fast Ethernet 0/1, fast Ethernet 0, sorry, it's fast Ethernet 0/2 and fast Ethernet 0/4. Now shut. Coming to S3, exit interface range fast Ethernet 0/2, comma fast Ethernet 0/4. Now shut. Coming to step 4, display spanning tree information. Issue the show spanning tree command on all 3 switches. The bridge ID priority is calculated by adding the priority value and the extended system ID. The extended system ID is always the VLAN number. In the example below, all 3 switches have equal bridge ID priority values, that is 32769. That is equal to, here we can see the priority plus the VLAN number, where default priority 32768, VLAN number is 1. Yes, so therefore the switch with the lowest MAC address becomes the root bridge, S2 in the example. Here we can see the command show spanning tree to display the spanning tree information. Bridge ID priority 32769. All 3 switches we can see this bridge ID priority will be the same, 32769, 32769, and also we can see the MAC address here, and here this is the MAC address for S2. We can see this is the lowest MAC address out of this S1, S2 and S3, and this switch become the bridge. Here we can, this bridge is the root, so this switch become the root. Right. Now we will verify the root bridge on our topology by giving this show spanning tree command. Coming to S1, password is Cisco, enable password is class, show spanning tree, and here we can see the details. Bridge ID priority 32769. Also here we can see the MAC address. Here we can see root ID address is this, but this switch is not the root bridge. Now we will come to S2. Cisco enable password is class, show spanning tree, and here we can see the address both are same here, and we can see this bridge is the root. So this will be the lowest MAC address among these 3 switches. Now we will verify on S3. Show spanning tree, and here we can see root ID address. Here we can see the MAC address of S2. Bridge ID, here we can see the MAC address of S3. Right. So in our topology, S2 is the root bridge. Here they given a note. The default STP mode on the 2960 switch is per VLAN spanning tree, that is PVST. In the diagram below, record the roles and status of the active ports on each switch in the topology. Coming to our topology, first of all we will go to the switch S1, and here we can see the interface fast Ethernet 0/2. The role is root, and here we can see the status is forwarding. Also we can see the interface fast Ethernet 0/4. Here the role is alternate, and here we can see the status blocking. So we can see those interfaces. This is fast Ethernet 0/4, which is blocking, and here we can see fast Ethernet 0/2, which is forwarding. Coming to S2, here we can see interface fast Ethernet 0/2. Here the role is designated and status is forwarding. Also we can see the interface fast Ethernet 0/4, role is designated, and status is forwarding. Coming to S3, here we can see the details. Interface fast Ethernet 0/2, role is root, and here we can see the status of forwarding. Interface fast Ethernet 0/4, role is designated, and here we can see the status forwarding. We can see those interfaces. So this is fast Ethernet 0/2 and this is fast Ethernet 0/4. Based on the output from your switches, answer the following questions. Which switch is the root bridge? So here now topology S2 is the root bridge. Why did spanning tree select this switch as the root bridge? Here first of all they will check the priority number, but on all these three switches they got the same priority number, and next they will check the lowest MAC address. So S2 is having the lowest MAC address, so this switch is selected as a root bridge. Next is which ports are the root ports on the switches. So coming to S1, here we can see the interface fast Ethernet 0/2 is a root port. Also on S3, here we can see the interface fast Ethernet 0/2, also root ports. Next is which ports are the designated ports on the switches. So here we have seen on S2 the ports that is fast Ethernet 0/2 and fast Ethernet 0/4. Also we have seen on S3 fast Ethernet 0/4 as a designated port. Next is what port is showing as an alternate port and is currently being blocked. So on this topology here we can see S1, the port fast Ethernet 0/4 is an alternate port and is currently being blocked. And here is the last question. Why did spanning tree select this port as a non-designated blocked port? So obviously the spanning tree algorithm uses the root bridge as the reference point and then determines which ports to block based on the path cost. Suppose the path costs are equal, then compares BITs. In our topology, we can see the link between S1 and S3 has the highest cost to the root bridge, and the path cost through both switches are the same. So the spanning tree algorithm selected the path through the switch with the lower BID and blocked the port. So we have seen that fast Ethernet 0/4 on this S1 on the switch with the higher BID. Now we will come to part 3. Observe STP port selection based on port cost. The spanning tree algorithm, that is STA, uses the root bridge as the reference point and then determines which ports to block based on the path cost. The port with the lower path cost is preferred. If port costs are equal, then spanning tree compares BIDs. If the BIDs are equal, then the port priorities are used to break the tie. Lower values are always preferred. In part 3, we will change the port cost to control which port is blocked by spanning tree. So coming to step 1, locate the switch with the blocked port. With the current configuration, only one switch should have a port that is blocked by STP. Issue the show spanning tree command on both non-root switches, that is S1 and S3. In the example below, spanning tree is blocking port fast Ethernet 0/4 on the switch with the highest BID, that is on S1. The same case on our topology also. Here we can see the output for a show spanning tree, and here we can see the MAC address of S1, and we can see the fast Ethernet 0/4 is alternate and blocking, because here we can see the highest MAC address. Also we will see the output of S3. Here we can see that. So if we compare these two MAC address, this is the highest MAC address. So root bridge and port selection may differ in your topology. Anyway, we'll check in our topology now. Coming to our topology S1, here we can see the output for the show command. Also coming to S3, Here we can see a BID. Also we can see the BID of S3 here. If we compare these two BIDs, we can see the highest BID on S1. Hence this interface fast Ethernet 0/4 considered as alternate, and we made the status as blocked. Coming to step 2, change port cost. In addition to the blocked port, the only other active port on the switch is the port designated as the root port. Lower the cost of this root port on 18 by issuing the spanning tree cost 18 interface configuration mode command. So here we can see that we will give this command on S1. Configure terminal. We have to go to that interface fast Ethernet 0/2 spanning tree cost 18. Here we can see invalid input detected. I think this command is not supporting in our packet tracer. Spanning tree unrecognized command. So this command is not supported in this packet tracer. Anyways, we can see the output they're given in this lab activity. Coming to step 3, observe spanning tree changes. Reissue the show spanning tree command on both the non-root switches. Observe that the previously blocked port, that is on S1, the port fast Ethernet 0/4, is now a designated port, and spanning tree is now blocking a port on the other non-root switch, that is on S3. The port is fast Ethernet 0/4. So we can see that by this show spanning tree command. Here we can see now the cost is 18, and here we can see the port fast Ethernet 0/4 is a designated port, and we can see the output of this show spanning tree command on S3. Here we can see the cost is 19 on fast Ethernet 0/2, and here we can see the port fast Ethernet 0/4 is now alternate and blocking. That means here on S3, after giving that command, this port will be going to be blocked. Here we have a question. Why did spanning tree change the previously blocked port to a designated port and to block the port that was a designated port on the other switch? Obviously, STP looks at the path cost first. The port with the lower path cost will always be preferred over a port with a higher path cost. Now coming to step 4, remove port cost changes. Issue the no spanning tree cost 18 interface configuration mode command to remove the cost statement that you created earlier. Anyway, we did not create on this S1, so I need to do that. Reissue the show spanning tree command to verify that STP has reset the port on the non-root switches back to the original port settings. It takes approximately 30 seconds for STP to complete the port transition process. Anyways, we are in original port settings. Now we will come back to part 4. Observe STP port selection based on port priority. So if port costs are equal, then spanning tree compares BIDs. If the BIDs are equal, then the port priorities are used to break the tie. The default port priority value is 128. STP aggregates the port priority with the port number to break ties. Lower values are always preferred. In part 4, we will activate redundant path to each switch to observe how STP selects a port using the port priority. So activate ports F0/1 and F0/3 on all switches. So we will do that. First of all, we will do it on S1. Password enable. We have to go to those interfaces as a range, fast Ethernet 0/1 and fast Ethernet 0/3, and we will give an offset command. Coming to S2, password enable, password configure terminal interface fast Ethernet 0/1 and fast Ethernet 0/3. Oops. we have to give us a range. No shut, and we will come to S3. Cisco enable password class, configure terminal, interface range fast ethernet 0/1 and fast ethernet 0/3. No shut. Coming to B, wait 30 seconds for STP to complete the port transition process and then issue the show spanning tree command on the non-root switches. Observe that the root port has moved to the lower numbered port linked to the root switch and blocked the previous root port. Here we can see a show spanning tree output. Here we can see a root port, fast ethernet 0/1 and all other blocking ports. Also here we can see on S3 root fast ethernet 0/1 and here we can see the blocking port. Same thing can be observed on our switches S1 and S3. Show spanning tree and here we can see that. Also coming to S3, show spanning tree. We got some questions here. What port did STP select as the root port on each non-root switch? Coming to our example, here we can see the port fast ethernet 0/1 on S1 and fast ethernet 0/1 on S3 are the root ports. Next is why did STP select these ports as the root port on these switches? Obviously, the default port value of the ports is 128. Therefore, STP used the port number to break the tie. It selected the lower port number as the root port and blocked the higher numbered port with the redundant path to the root bridge. Also, we got some reflection questions here. After a root bridge has been selected, what is the first value STP uses to determine port selection? Obviously, path cost. It selects the path with the lower accumulated cost. Second question, if the first value is equal on the two ports, what is the next value that STP uses to determine port selection? That is a bridge ID by selecting the lower value. And the third question, if both values are equal on the two ports, what is the next value that STP uses to determine port selection? So an aggregation of the port priority and the port number, the lower value is preferred. Well, that's all in this lab activity. That is building a switched network with the redundant links. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.